Hello students, let us discuss one of the lessons for this week, which is solving radical equations. The goal of our lesson is to solve equations involving radicals, then to identify extraneous solution, if any. Let us start by defining the radical equation. A radical equation is any equation that contains one or more radicals with a variable in the radicand. Some examples are the square root of x plus 1 is equal to 5, the square root of y minus 2 is equal to the square root of 10, the cube root of 4x minus 7 is equal to 6, and many more. In solving radical equation, we need to follow this rule. If a is equal to b, then a raised to n is equal to b raised to n. To solve equations with radicals, we need to follow these steps. First, place the radical expressions on one side of the equation. Second, raise both sides of the equation into an exponent equal to the index of the radical expressions. Then last, solve and check if the solution will satisfy the equation. Now, let us answer some illustrative examples. Number 1, the square root of 2x is equal to 4. The first step to solve radical equation is to place the radical expressions in one side of the equation. But in this equation, it is already placed on the left side of the equation. So, we can now proceed to step number 2, which is raising both sides of the equation into an exponent which is equal to our index. As you notice, our index is 2. So meaning to say, we need to raise both sides of the equation into 2. So that is the square root of 2x raised to 2 is equal to 4 raised to 2. The square root of 2x raised to 2 is already 2x. 4 raised to 2 is already equal to 16. Then, let us apply the division property of equality, dividing both sides by 2. 2x divided by 2 will give us x. Then on the right side, 16 divided by 2 is equal to 8. So our solution is x is equal to 8. Next, we need to check if the solution will satisfy in our equation. So that is the square root of 2x is equal to 4. Then substitute the value of x, which is 8. So that is the square root of 2 times 8 is equal to 4. The left side of the equation, the square root of 2 times 8 is equal to the square root of 16. Then it is equal to 4. The square root of 16 is equal to 4, which is also equal to our right side of the equation. So that is checked, meaning to say 8 is really the solution for this equation. Next, number 2, the square root of x plus 1 is equal to 5. The same with number 1, the radical expression is already placed on the left side of the equation. So we can now proceed to step number 2, which is raising both sides of the equation into an exponent which is equal to our index. As you can see, our index is 2. So meaning to say, we need to raise both sides of the equation into 2. So that is the square root of x plus 1 raised to 2 is equal to 5 raised to 2. The square root of x plus 1 raised to 2 is equal to x plus 1. Then, 5 raised to 2 is equal to 25. To eliminate 1 on the left side, we need to use the addition property of equality. So that is x plus 1 minus 1 is equal to 25 minus 1. The left side of the equation will now become x is equal to 24 because 25 minus 1 is equal to 24. So our answer or our solution is equal to 24. Now let us check. The square root of x plus 1 is equal to 5. Then let us substitute the value of x, which is 24. So that is equal to the square root of 24 plus 1 is equal to 5. The square root of 24 plus 1 is the square root of 25, equal to 5. The square root of 25, which is equal to 5, is the same as 5 on the right side. So that is checked. So meaning to say 24 is really the solution for this equation. Now let us answer number 3. The fourth root of y minus 2 is equal to the fourth root of 10. This is the same with number 1 and 2, wherein the radical expressions with a variable is already placed on the left side of the equation. So let's proceed now to step number 2, which is raising both sides of the equation into exponent equal to the index. Since our index is equal to 4, so meaning to say we need to raise both sides of the equation into 4. That is, the fourth root of y minus 2 raised to 4 is equal to the fourth root of 10 raised to 4. The fourth root of y minus 2 raised to 4 is already y minus 2. The fourth root of 10 raised to 4 is already equal to 10. To eliminate negative 2 on the left side, we need to use the addition property of equality. So that is y minus 2 plus 2 is equal to 10 plus 2. Y minus 2 plus 2 is already y is equal to 10 plus 2 is equal to 12. So our solution is equal to 12. Now let us check. The fourth root of y minus 2 is equal to the fourth root of 10. Let us substitute for the value of y, which is 12. That is fourth root of 12 minus 2 is equal to the fourth root of 10. The fourth root of 12 minus 2 is equal to the fourth root of 10, which is the same as the fourth root of 10 on the right side. So meaning to say, our solution is really 12. Next, number 4. The fourth root of 4x minus 4 is equal to 6. The radical expressions is already placed on the left side of the equation. So let's proceed to step number 2. We need to raise both sides of the equation into 4 since our index is equal to 4. That is, the fourth root of 4x minus 4 raised to 4 is equal to 6 raised to 4. The fourth root of 4x minus 4 raised to 4 is already equal to 4x minus 4. 6 raised to 4 is equal to 1,296. Then let us eliminate negative 4 on the left side. So we need to follow the addition property of equality. That will become 4x minus 4 plus 4 equals 1,296 plus 4. The left side of the equation will now become 4x is equal to 1,300. Dividing both sides of the equation by 4. So 4x divided by 4 is equal to x. 1,300 divided by 4 will give us 325. So meaning to say our answer or the solution is equal to 325. Then to check, the fourth root of 4x minus 4 is equal to 6. Let us substitute the value of x, which is 325. So that is the fourth root of 4 times 325 minus 4 is equal to 6. The product of 4 times 325 is equal to 1,300 minus 4 is equal to 6. The fourth root of 1,300 minus 4 will give us the fourth root of 1,296, which is equal to 6. The fourth root of 1,296 is equal to 6, which is the same as 6 on the right side. So meaning to say, 325 is really the solution for this equation. Number 5, the square root of x minus 2 plus 4 is equal to x. Here we need to apply the first step of solving radical equation, we need to isolate the square root of x minus 2 on the left side. So we need to transfer positive 4 on the right side. So it will now become the square root of x minus 2 is equal to x minus 4. Then let us raise both sides of the equation into an exponent of 2 since the index is 2. So that is the square root of x minus 2 raised to 2 is equal to the quantity x minus 4 raised to 2. The square root of x minus 2 raised to 2 is now equal to x minus 2 is equal to the expanded form of the quantity x minus 4 raised to 2 is equal to x squared minus 8x plus 16. By addition property, it will now become 0 is equal to x squared minus 8x minus x plus 16 plus 2. Combining like terms, it will now become 0 is equal to x squared minus 9x plus 18 because negative 8x minus x is equal to negative 9x. 16 plus 2 is equal to 18. This is the same as x squared minus 9x plus 18 is equal to 8. To solve, this is already a quadratic trinomial. We need to factor, that is quantity x minus 3 times the quantity x minus 6, which is equal to 0. To solve for the first variable, we need to apply the zero product property, that is x minus 3 is equal to 0. This means the first value of x is equal to positive 3. And then on the other hand, x minus 6 is equal to 0, which will give us the second value of x, which is equal to 6. Meaning to say, there are two possible answers, which is 3 and 6. Let us check if the two possible solutions will satisfy our equation. First, if x is equal to 3, the square root of x minus 2 plus 4 is equal to x. Substitute the value of x, that is the square root of 3 minus 2 plus 4 is equal to 3. The square root of 3 minus 2 is equal to the square root of 1 plus 4 is equal to 3. The square root of 1 is equal to 1 plus 4 is equal to 3. The left side of the equation is now 5 equals 3. As you notice, 5 is not equal to 3. Hence, 3 is not a real solution. It is just considered as extraneous solution. Next, let us check if the value of x, which is 6, will satisfy our equation. The square root of x minus 2 plus 4 is equal to x. Substitute 6, that is the square root of 6 minus 2 plus 4 is equal to 6. The square root of 6 minus 2 will give us the square root of 4 plus 4 is equal to 6. The square root of 4 is equal to 2, and then plus 4 is equal to 6. 2 plus 4 is 6, which is the same as 6 on the right side. So that is correct. Therefore, 6 is a real solution.